I think we might be live. Um, there we go. Give this a few minutes to stop lagging. Okay, we're live. Welcome to the first in the weekly series of live streams where I'm going to cover the basics of the CyrCraft LED Cyr wheel system that we've been working on. And yeah, let's jump into it. I got to look at my cheat sheet here. So I'm going to start out this stream with just an overview of different things in the system, and then what we're going to be focusing on after that overview is the basics of LED pattern animations and synchronizing LED animations to music using our desktop pattern and sequence editor that we'll be showing in a few minutes here. So to start out with, let's look at a couple pieces that are in the system. I'm going to jump over to the side bench here, and we're going to just take a real quick look at our wheel hardware. So there's three basic pieces to the wheels, and let me show them one by one. So we've got essentially the frame here, which is artfully represented here by this arc. So the frame has the LEDs inside of it. If we look over at the other table there, that's your LED wheel frame. It has the couplers in the end of it on the ones that you're looking at right there to make the connection between sections. And yeah, so essentially this is a placeholder for the LED wheel shell, we'll call it, or the basic frame. Inside of the frame, we add a coupler assembly. Let's see. There we go. There it is. So our coupler assembly makes the connection between two sections of wheel, and also makes a connection to the wheel's internal components that drive the LEDs. So that assembly is called the power pack. The power pack is easily easily removable. I am getting over a cold. I'm going to be coughing. I'm still a little bit congested. Apologize. That's going to be a little bit annoying throughout the broadcast here. But so we've got a removable power pack that holds the battery. It holds the LED wheel controller, and it makes the connection to the next section of wheel with a connector down here. And if I show the next section of wheel here, we can see kind of how that looks when two sections come together. And let me jump over to the other table and just kind of show that a little bit in person. Now, I am showing this with older hardware. This is our design we were using before the pandemic. All of the internals have changed. I can't actually show the internals yet because we're working on we're finalizing some patent stuff. And over the next few weeks, I will be showing how the internals all work. But just as an overview, it's kind of like what you see on this one, where there's some connectors on the end. There's an internal frame with some connectors. I don't know if you'll be able to see down inside of there. And when you put the wheel together, the connections just automatically are connected to each other. And you can power the wheel on and off with a little plug in each section. Each section has its own battery. Apologies again, I can't show more on the hardware than that for today until we finish up some of our patent applications. But yeah, so that's the overview, very basic overview of the hardware. This system does allow you to either charge a battery while it's inside the wheel, while it's fully assembled, You can charge every section of the wheel while it's assembled, or you can, if you don't want to wait to charge a battery, you can quickly pull the internal power pack out of the wheel and swap the battery out of it. The logic board that's controlling the LEDs, it has an SD card. This is how you're going to get your patterns on and off the wheel. It also has Wi-Fi. We are still working on setting up the system so that we can just send patterns to the wheel over Wi-Fi. But everything is held on an SD card, so you can have hundreds or thousands of patterns on your wheel. You can have many different sequences. And you probably never use a fraction of the storage on the SD card. The SD card is nice because it also lets you just quickly swap in and out different, well, actually we'll get into that more when we talk about the programming side of it. So anything else I want to say about the kind of system overview? Basically everything in the wheels is modular and easy to swap out, replace. You can interchange it with any other section of the wheel, any other size wheel from our LED wheels, and it's all just dialed in to be modular and replaceable, because in the course of traveling the world and performing with these things, you're going to have parts that get lost or broken, or you forget to charge a battery, and or you run over a pebble and you break an LED and you want to replace an LED strip. It's all been designed to make all of that quickly, easily replaceable, and with a big focus on user friendliness. A lot of the redesign I've been doing the past few months has been to make it so that you don't have to do any troubleshooting. You need very little technical ability to be able to figure out what might need to happen in order to replace an LED strip, or swap out a battery pack, things like that. I just want it to be really, really simple. So that all said, let's jump over to well, let me check my list here. I think we're ready to start looking at the basic programming concepts. How do you get patterns, different LED animations to display on the wheel? How do you control them? How do you program them? How do you set them up? And we're going to start kind of from some basic concepts, and I'm going to jump over to a different screen here. There we go. All right, so what we're looking at here is we're looking at our pattern editor, our pattern visualizer inside of the Star Pusher desktop app. So Star Pusher is basically what you see here. It's what you see is what you get editor. So in Star Pusher, we have a bunch of different tabs for different interfaces. There's a project manager tab where you can control some of the global properties of a project, and we'll get into what a project is in a little bit. There's a file browser where you can drag stuff from your file system in general into your current project. We've got a single pattern formatter, a batch pattern formatter, a pattern visualizer, and then a pattern sequencer. The pattern sequencer is really the kind of meat and potatoes of this whole system, and it's essentially set up like a video editor or an audio editor. So if you're familiar with any timeline editing, it's very similar to that. But before we get into the complexity of that, we're going to start with the basic pattern visualizer to get an understanding of what's going on when we're trying to get the LEDs to do something. So here, the first thing to understand is that every LED pattern on our wheels is just a basic 2D image that's being animated. you can see we've got this image of like a lightning bolt. And the way it's animated, let me switch into line view here. Essentially and I'll turn off duplication, and I will make this the same width as the line. Okay, now it's a little easier to understand. So what is happening here is down in our lower right-hand corner here, you can see that we have our image. We can also see this kind of scroll bar that I can drag across the image, and I'm essentially just inspecting and displaying one row of the image at a time. And we'll see that in our line view. So our line view makes it kind of easy to understand what is happening as this 2D image gets translated to an animation. We're looking at one row at a time of this image that gets mapped to the LEDs that are wrapped around the wheel. And if I just let this, if I let that scroll bar go, it plays through, and it's playing through right now at a certain frame rate. It's 80 frames a second. So there are 360 rows in this image, and we're playing them at 80 rows a second, 80 frames a second. If I slow this down to 20, you can see it displays the same animation a lot slower. This is the basic concept of how we get the LEDs to animate. You're going to start out with a 2D image. We supply a lot of open source images with our wheels. When you get a wheel, you'll have access to a library of tons of different images, and you can also modify your own. You can modify them in the software here. We'll get into that in a moment. You can make your own in any image editor, and Star Pusher you bring them into Star Pusher will format them properly for the wheel to display. So let's do a couple things with this image. I'm going to switch from line view back into wheel view, and essentially what we're having, what you see here, is it's that same line, but it's wrapping it clockwise in a circle so that we can see what it will look like on a wheel. Now, there are a specific number of LEDs in each wheel. I am using 360 LEDs for the purpose of this demonstration. 360 is a number that's divisible by a lot of other numbers. It's nice to work with. It's also the number of LEDs that is in a 73-inch LED sear wheel. It's the number of LEDs per strip. There's over 1,000 in a wheel because we have 3 strips in parallel around the wheel, but I don't want to go too far down into the weeds talking about that yet. But essentially, we've got 300, and we can see the tooltip, we can see what LED we're on. So we're actually seeing, excuse me, we're seeing what one row of the image looks like mapped on to the circularity of the wheel. All right, so now is when we can start to think about, okay, how do we modify this and make this do some cooler stuff? Let me check my notes here to make sure I'm not forgetting anything before I move forward into that. All right, so we've covered that an LED animation is essentially a 2D image that's mapped to the circle displaying at at a certain frame rate. So by changing, we can get, back up, so with one image, we can actually get a number of different effects just by changing the width of the image, how that image is mapped to the strip of LEDs, and the frame rate. So I already showed you what happens when we adjust the frame rate. It just moves through, it scans through this image slower. We can also change the width of the image. If I change this to 180, then I get the same animation. It's only mapped across the first half of the wheel now, since the wheel is 360 pixels long. and our image is 180, it only maps it to half of it. But we have this option here. You can turn on duplication. So it's on by default if I don't have it activated here. So I have all these pattern settings here I can use, and I can turn duplication on and off. And what that does is it plays it once, and then it plays it again around the wheel. If I change this to 90, we'll see that pattern played 4 times around the wheel. If I change it to 72, we'll see it played 5 times, etc. If we turn duplication off, then it only plays along the first 72 pixels. And I can actually turn on duplication points here to see, you know, from LED 1 to LED 72 here is what it's displaying that image on, because it's a 72 pixel wide image at this point. I can also make it play through a lot faster by changing the height of the image. So now there's only 90 rows to go through, and it's playing them at 80 rows a second, so we're getting roughly 1 second per cycle here. So you can use either frames per second, and it's better to keep a higher frames per second because you get a smoother playback. But you can change frames per second or height to change how quickly it plays back. So I kind of like the way it looks at 180, and I'll make it even smaller at 60, and it shows us our duplication points here. It would play that 6 times around the wheel of 360 LEDs. And so with this, I don't have, in a future, we'll get into some of the details of how we can map the accelerometer output to this to have this this kind of cool, I don't know, comet shape actually move around the wheel in reaction to motion. That's something, you know, I think I probably have, let's switch monitors here. I probably have an image or a video of that here. Actually, here we go. No, not that one. One of these is showing some of the gyro effects that you can get. Maybe here. Yeah, so we get these gyroscopic effects, which react to your motion, to the motion of the wheel. And so this is actually probably duplicating a single pattern 4 times around the wheel, and then applying a gyro mapping to it. So let's jump back into this, and we'll, so if we turn duplication on, you can see that it duplicates it across each of those sections, 60 LEDs at a time. You can also take a look and see what each section of the wheel specifically is lighting up. You know, it's helpful sometimes when you're trying to figure out how to fit a certain image, etc., onto the wheel. All right, so what's next on my list? Look at my cheat sheet here. And okay, I'm going to check, let's see. Bear with me here. Okay, so next, let's get into some of the other features that we can change with this. I can change the direction of the image and get a completely different effect. Let's change this back to 360, and now we can see we're mapping this in a completely different way. So you get the idea that we can change very basic details of the same image in order to get very different effects from one image. So with that, I think we're ready now to jump into the pattern sequencer So I need to, first I'm going to bring in, if I can find it, I'm going to bring in there we go. So I'm just dragging in an audio file. And if, I think I need to turn on system audio, don't I? Let's make sure that you guys are getting system audio here. And
I came from the mud. There's dirt on my hands. Strong like a tree.
okay, cool. So we've got audio here, so you can actually hear what I'm doing. Now, I'm going to go back up, and we're going to drag some patterns into the timeline to see how that works. So in the first few seconds of the song, I probably want to start with something, I don't know, something kind of gentle. Maybe have this image pulsed in and out.
I came from the.
Okay, cool. So we get a little bit of pulsing as the song starts, and then we want to jump into maybe something a lot more energetic as that big crash hits. So we'll drag, maybe we'll drag this in there. And you can zoom in on the timeline, same as you would in any editor. Okay, let me come back here. Let me drag this here. So
I came from the mud. There's dirt on my.
okay, cool. And then at this next hit, maybe I want to switch to something completely different. Was it right about there?
My hands. Strong like a tree. There's roots where I stand. Where I stand. There's roots where I stand. There's roots where I. There's roots where I stand.
So that one doesn't work. You can just get rid of that one.
There's roots where I stand. Where I stand.
So you're starting to get the idea. You basically just drag stuff into the timeline.
I came from the mud.
All right, so this pattern, I want to maybe slow that down a bit. So I'm going to change the height up to 180. And I want to map it differently. I want to have it maybe repeat 3 times around the wheel. So we'll go 360 divided by 3 for 120. Let's see what that does.
I came from the mud. There's dirt on my hands.
And actually, I think it'll look cooler if
Came
this.
from the mud. There's dirt on my hands. Strong like a tree.
So you get the idea. You can change the effects of all these patterns and watch it in real time in the timeline. All right, so those are some basic programming concepts of the wheel. There's a lot of other stuff that you can do with the Star Pusher app. We've got all these different tabs here. Now that I've shown you some of this I want to get into a little bit more of what a project is, how you manage a project. Essentially, there we go, now you can see me. So essentially a project is all of the files that you're going to put onto an SD card and put inside of your wheel. The SD card has to have the files structured in a certain way in order for it to find the right patterns and start them with the right commands, etc. So Star Pusher manages all that for you when you create a project. You can use Star Pusher without creating a project and then do some of this stuff manually. But it can get confusing making sure you have things structured in the right folders and named appropriately. So Star Pusher handles all of that for you. And as you are compiling different patterns and saving different configurations of those patterns, changing the width, height, playback speed, gyro, accelerometer, mode, etc. Star Pusher will kind of manage keeping all of those files and all of the configurations in the right order so that you can just then write that entire project to your SD card, put that in the wheel, and know everything's going to work the way you expected. So let's see. Let's look at the Project Manager tab here. So here is where we're going to set some kind of global variables for each project. You can have different presets, different audio tracks that you are mapping things to. You can choose what folder is your default folder, the number of LEDs in your wheel, essentially wheel size. We're probably going to add a toggle here so that you can either enter it as number of LEDs or as wheel size. You can name your project, set default brightness of the wheel. There's a status LED that you can configure to be on or off, either globally or per pattern or per sequence. But basically you have all these global settings that are going to just be the default as every pattern plays in your wheel, unless you have set local pattern settings for a pattern that override that. So we've also got a single pattern formatter here, which shows you the difference between the raw input file, so like that lightning bolt file that we were looking at earlier. This is what it looks like, and this is what it looks like with all of our changes applied to it. So I can, I've got it rotated, I can undo the rotation, I can change the height back to, I think it was originally, I don't know, something smaller. It's like 45 maybe. And the width, oh, sorry, yeah. I think I've got an issue here where the screen is not big enough. Okay. Okay, so we've got a few things to work out to make sure that that this will fit on all different size screens. I'm intentionally using a monitor for this that is only, I think, 1400 pixels wide. So on most monitors, this will play just fine, or this will display just fine. But if I change this now to 45, we can see we kind of start to get back to what it originally was. So you can look at the actual differences you're making to the file before you export the image with any of its new settings. We've also got a batch pattern formatter, which essentially looks exactly the same, except for rather than loading a single image into the input viewport here, you can load an entire project folder or an entire sequence into that and resize it for another wheel. So if you are in the pattern sequencer and you're setting up a performance that ultimately you want to have run on several different size wheels. You can program it once for one size wheel, and then you can just bring it into the batch formatter, drop that sequence in there, and it will resize all of the files to another wheel size. And essentially, right now it's set so that there's a couple changes to make, because right now it changes them all to one size, and sometimes you want to have multiple different sizes. So we have some more work to do on that, depending on how many times you want to duplicate the pattern, etc. And we've also got, I think I've actually walked through everything. We've got the file browser. You can pull stuff from your general system into your current project. And we're working on adding a help page as well. So that will show you what all the hotkeys are in the different tabs of the program. Mainly pattern visualizer and pattern sequencer are where you're going to use the keyboard shortcuts. And you can also send a debug log if you're having any issues with the application. It will send us a log of basically all your actions from your current session. And I think it actually keeps a log file that's separate, and so it will send it from the past several sessions. And anyways, we'll be able to see what you did and see what problem you're having. We need to add a little text box feature so that it sends a note, so you can explain the issue that you're having or that you've had when you hit that. And I think that's all I'm going to cover for today. At this point, it looks like we actually didn't have any live viewers or comments here, so at least not in what I can see. Let's see. There we go. So, yeah, I was going to do a Q&A at this point, but I don't think we have any questions. So, I guess you can watch me sit here awkwardly trying to think of if there's anything else that I wanted to share with this. I'm going to look through my cheat sheet, my notes here. Oh, here we go. So Star Pusher is going to be sent out to everybody that's on the backlog in the next few weeks. As you can see, there's a couple things in here that need to be tweaked. Nothing that makes it unusable, but there's improvements still to make and kind of some bug fixes to do in order to get this out to everybody. So in the next few weeks, we'll be sending a version of this out. And I also wanted to, I think, talk about persistence of vision. So let me jump back to this monitor where you can see. So yeah, if you saw our Instagram, you know that we can do persistence of vision. So logos, text, etc. We can have that displayed on the wheel as it's moving. And essentially all that is that's just an image that has the word CyrCraft on it. It's duplicated twice around the wheel. And then we pick a frame rate of 80, works pretty good for POV images like this. And there it is. So anything else here? A lot of the stuff that you might see in here is actually obsolete. So keep your eyes peeled for more of these over the next few weeks as we get into kind of updating where the system is currently at. In future weeks, again, we're going to focus more on the hardware side of things after we get some patent applications tied up and we are able to share what's going on with that. And so we'll cover things like basically how you're gonna put your wheel together, how how the connections are made, how to replace an LED strip, all that stuff to do with the hardware of the wheel. Yeah, I'm gonna learn as I go with setting up these live streams to be more helpful and maybe kind of narrow down and focus on smaller aspects of this, because there's I've really only like just kind of touched the surface of what our LED controller can do and what the desktop software can do, and so we're gonna be doing a lot more of these. And with that said, thanks for watching, and I will see you guys next week. Now I gotta figure out how to end this live stream.